Alright, so problem 16, we're dealing with a disk. A disk, and it's rotating about a central axis, like that, and starts off going at an initial angular speed of 10 revs per second, and after 60 revolutions, after 60 revs, it has an omega final of 15 revs per second. So this is just a straight up kinematics problem, and we know that we can use kinematics because the acceleration is constant. And part A is asking us to find this acceleration, so we can just use omega final squared equals omega initial squared plus 2 alpha delta theta, and we know that this is 15 and this is 10 plus 2 alpha, and this is 60 revs. You may be asking, I thought we had to convert everything to radians, from revolutions to radians. That it depends on the problem and what it's asking for, but just as if we were dealing with linear kinematics and we, instead of using meters, we could have used centimeters or even feet, you should be able to see that revolutions is still a valid unit of angular displacement, or we could even use degrees instead of radians. They would all be valid in here as long as we're consistent. And it doesn't ask us particularly to use radians in this particular problem, so yeah. Anyway, solve for alpha, and you get 1.042 revs per second squared. Part B, it asks how long it takes to go from 10 to 15, or in other words, how long it takes to do these 60 revs. We could just use this kinematics equation. Plus alpha t. And we know this, and we know this, and we just solved for this. 1.042. This is slightly rounded, so you don't want to round if you're using WebAssign. T, and solve for t, and you get 4.8 seconds. Part C, it's asking how long it took to reach 10 starting from rest. So that's same equation as part B. That's an alpha. Horrible. We go to 10 from 0 at the same acceleration of 1.042 times t, and solve for t, and you get 9.6 seconds. And finally, part D, the number of revolutions from rest until 10, so the number of revolutions during this time period. So we could use this one, this equation, delta theta equals omega initial t plus 1/2 alpha t squared. And we're looking for this, so we just know this is 0 plus 1/2, same acceleration, 1.042 times 9.6 squared. That's the time it took to do this type of motion, and you get delta theta equals 48 revolutions. And that's it. Not too bad.